the area of a triangle. So hope we've been doing area of a triangle for years now. Area of a triangle is 1/2 base times height. That's the most common area of a triangle formula we know, right? But the one thing about that formula is that it requires the height. So height is always synonymous with the right angle. So like here the height's there, here the height's here. Even when it's a scaling triangle like this, the height would be the outside part. The right angle is the height. So area of a triangle is 1/2 base times height. But what if we don't have the height? Now you could go through the work of trying to find the height. That's true. But we have a new formula that this requires you to find the angle and the two sides in between. I said that wrong. Two sides and the angle in between are included. So if you have, say you have something like this, then that's all you need to find the area of a triangle. So before we do that, let's talk about how we label a triangle. When you have a triangle, what we generally label is all the angles as capital letters. So you can see angle A here, angle B there, angle C there. And then the sides opposite them are lowercase. So angle A, opposite lowercase a. Angle B, opposite lowercase b. Angle C, opposite side lowercase c. I might still lowercase c twice on that, but I mean capital C for the angle, lowercase c for the side. Now here's a generic form we have. Area equals 1/2 AB sine C. That just comes from the mathematics of solving the height of any triangle and working it out. But the formula is 1/2 AB sine C. This is in the formula sheet. The key to this though, that the letters don't mean a thing. All that matters is that it's two sides and the included angle. That's all that matters. So I could do, let's see, if I give you side BC and side AC, then the angle I would need would be angle C. Right? It's all about having two sides and the angle included. As long as you have that, you can find the area of a triangle. Right? So the ABC don't really mean anything besides they stand for two sides and the angle included. That's all it stands for. So you need something like this, and you can find the area. So side, include angle. All you need. Letters don't mean a thing. So let's do an example. Find the area of this triangle. So all I need to know is that do I have a side, the side next to it, and the angle between it included in it. And yes, I do. So I just know it's 1/2 AB sine C. I don't even care about what the letters are. I just care that it's two sides that I have, 11 and 15, and the angle included. So sine of 28. And then all I have to do is plug it into a calculator. So it's like this. So we're going to go 1/2 or 0.5 times 11 times 15 times sine of 28. And I get 38.7 approximately. Remember we're doing area, so if I have units, it would be in that unit squared, because area is always squared. And there we go. That's the area of this triangle. Right? It beats, another way we could do it if we want to is make an altitude right there. Use SOHCAHTOA, because we have 1128 to find the height of that altitude. And then do 1/2 base times height. A little more work though. A rhombus has a side length of 12 centimeters and an angle of 72. Find its area. So rhombus is like a slanted square. So something like this. Not my best. So since it's like a square, all the sides are equal. And it has an angle of 72. So I would say the shorter one is 72. I could find the other one if I want to. I don't need it. I'm just trying to find the area of the rhombus. Well, it's a rhombus, right? So you could, if you want, try to make an altitude and do base times height. But we're going to use the trick of triangles to do this. If I make that cut there, then I have a triangle where the angle is 72 and each side on the outside is 12, right? Because it's a rhombus, all the sides are matched. So I have a triangle, have an isosceles triangle with 22, 22, and 72 degrees. Well, all I need is two sides and angle between, and that's what I have. I have a side, and the angle in between. So area is equal 1/2. 12 times 12 times sine of 72. Now there's a little shortcut if you notice, but I'll talk about in a second, to find the area of the rhombus. But we'll plug this in first though. 12. So 1/2 12 times 12 times sine of 72. And we get approximately 68.5. Again, 366. But that's the area of the triangle. That triangle is only half of the area of the rhombus. So to get my final answer, area of the rhombus, I was going to get that and times it by 2. And that'll give me my answer. I'll go back to my calculator. Again, when I have values in my calculator, let's keep it the way it is. I'm going to put times 2, so answer times 2. Now round it to 366, which would be about 137. Approximately. And remember, that is unit squared, so centimeters squared. Something like that. Right, so you find the area of one of them. Since the rhombus, you can times it by 2 to get the whole area. More, a triangle has two sides with a length of 10 and 11 and an area of 50 centimeters squared. Determine the possible measures of the including angle. Give your answer accurate to one decimal place. Now, this is something we're actually talking about later on in the chapter. Determine the possible measures of the including angle. I will do it here, but we're going to talk about in detail about where that comes from and why is it like that. But let's start first with the question at hand. The triangle has two sides. One length of 10 and the other length of 11. And an area of 50. Determining the possible measure of the included angle. So the included angle would be the one that's right here. No matter how you draw your triangle, right, that's the included angle. So how do I do this? Well, we know what the area is, so what's the form for area? The form for area is 1/2. I was about to say base sine side, but now we have AB sine C. So we know the area, we had a formula that 1/2 AB sine C equals 50. Do I know my A, B, and C? Well, I know my A and B. One of them is 10 and one is 11. It doesn't matter which one's which. So let's say A and B, and that's your C. So 1/2 10 times 11 times sine of C equals 50. That's just mostly a math problem. To simplify this, I get 1/2 times 10 is 5. 5 times 11 is 55. So 55 sine of C equals 50. So sine of C equals 50 over 55. We'll take the arc sine of both sides, or sine inverse of both sides. And we'll get C equals, I'm going to calculate first to do that part. So we're going to do arc sine of 50 over 55. Maybe about 65.4. One decimal place. So that's my first answer. Now, like I said, we'll talk about this ambiguous case a little bit later. But the general hint I'm going to give you here is if they ever ask you about multiple angles, they generally mean the ambiguous case. And what they want you to do is get 180 and subtract it from the answer you found to get the other one. A lot of times when you have two separate like C's or any letters, we'll put one with the C and one with the little C prime. That lets you know it's the reciprocal. It's the opposite of that one. The complement of that one, to more accurate, the complement of this one. Anyway, if you simplify that, you get, it's at 114.6. 114.6 degrees. And that's generally the strategy here. If they ever ask you about multiple angles, like multiple possible angles, you just get your angle you find and subtract 180 from it. Again, we'll talk more about in detail why we do that later. Anyway, last one, find the shaded area. So I gotta find the shaded area using the skills we know. So we know the area of a triangle now. It's good and it's helpful. But I need this whole area here. We did that earlier, area of a sector. So all we want to do here is find the area of the whole sector minus off the area of that triangle. If you do that, you're going to get what we want, which is area of this guy. So that's the plan. Now, do you remember how to find the area of a sector? That was the angle over 360 times the area of a circle, which is pi r squared. Right, so basically, what portion of the circle you want to keep times the whole area of the circle. Area of a triangle we talked about earlier. area is going to be 1/2 AB sine C, where C is the included angle. And then this is what we're trying to get. So let's do our first one. All right, so what do we need? The radius, 7, done, and we need the angle, 135. Couldn't be easier. So we have 135 over 360 times pi times my r, which is 7 squared. I just put that on the calculator, simplify, but I'm going to leave it here for now. The next one, I need area of the triangle, so it's 1/2 AB. 1/2 AB sine C. Now here's my triangle. Do I have everything? I have the angle, 135. I have one of the sides, but even with that, I should know the other side. It's a triangle, right? Well, it's a radius. It goes from the center to the edge. So if this is 7 centimeters, so is this one. So I have my two sides. So my area for this is going to be 1/2 7 times 7 times sine of 135. And all we gotta do is get the answer for this one, subtract off the answer to that one, and hopefully it's smaller and we get our actual answer. So let's do this real quick. So I'm gonna get 135 divided by 360 times pi times 7 squared. About 57.7. Then we're subtract off 1/2. Now you can put this all in one line. Since I'm teaching, I like to show steps. Times 7 times 7 times sine of 135. You get 17.324. Then we subtract those two values. So I'm going to select this one minus selecting the other one. And then here's where we should simplify to 360, so it'll be 40.4 millimeters squared. And that's the video.